Okay, kids, we all know that we have this nice little radioactivity handout. Yep, nuclear processes, pretty sweet. It does have a lot of good stuff on here. Want to go through a little bit of it. The beginning of it, right up here, radiation, radioactivity. Look, radioactivity. We have all heard these words before, and we know that when something is radioactive, like in the movies, it's really dangerous. It usually is, otherwise it wouldn't be radioactive. It usually is. You know, they got the Geiger counter out. Stay away from that stuff. That's where the alien comes out. Yeah, yeah, you've seen it. Yeah. So radioactivity means, if something's radioactive, it means it's unstable. There are many, many different forms of isotopes. All right, you know what an isotope is, right? Oh no? Okay. Well, ISO shirts, ISO hats, ISO pants sometimes, and sometimes isotope. Funny. All right. An isotope. It's just a different form of an element. Every element is not created equal. Like, for example, there are different forms of carbon, different forms of hydrogen. These are isotopes, and the isotopes are radioactive, okay? They're unstable, which means they want to break down. They want to become more stable, so they're kind of going like this. I'm tritium, and I don't want to be tritium anymore. Help me, help me. And so if you give off a little bit of radiation, then that'll, okay, feeling better, right? It'll settle you down. And if you give off more radiation, okay, feeling pretty good. Yeah, that's radiation. Its job is to make something less unstable. I was going to say less stable, less unstable. So if you're a radioactive isotope, let's for example, I just said tritium. So hydrogen, good old high quality made in America hydrogen. Right? Now we all remember what these are, right? Yeah, I know. It's a little bit of chemistry. Well, actually, it's physics. Chemistry just borrowed it from us. We'll let them do that. Chemistry's okay. All right, so this is what we got. We've got hydrogen, deuterium, duet 2, tritium, tri 3. Those are the different isotopic forms of hydrogen. And why are they isotopes? What makes them isotopes? Well, first of all, we all remember that this up here is your atomic mass. And we know that the mass is equal to the amount of protons and neutrons. You knew that. You just forgot it, right? Yeah, you did. But it's okay. It's all right. So I'm here for you, okay? This is the atomic number. So this is the atomic number. This is the amount of protons. And in fact, this is the one that makes an atom or an element, a kind of element, what it is. If you have one of these, you're hydrogen. Oh, you might be a different form of hydrogen, but you're hydrogen. If you have one of these, you're hydrogen. If you have two of those, you're not hydrogen anymore. Okay, you're not in Kansas anymore, Toto. You are helium, and we all know that's what they do at hospitals. Helium, funny. So helium has an atomic number 2 protons, and a mass number of 4. That's good old high quality made in America helium. Now, oh, by the way, it is made in America. Well, not made in America. There are deposits of it in Texas where we get helium from. Helium is a very rare element on the Earth. You know where there's lots of helium? The moon. It's one reason they want to think about going back to the moon to harvest helium out of the moon. Yeah, I'm not making this up. No, you check it out. Yeah, don't trust me. Because I went here to college. You don't want to trust anybody who went here. Okay, so this is helium because it has 2 protons. That's the mass number, protons and neutrons. And if we subtract those, we get the number of neutrons. So 4 minus 2, anybody calculator get that? 4 minus 2? 2? Okay, trust you. So 2, this would be 2 neutrons. So helium has 2 neutrons, 2 protons, a total mass of 4. Let's go back to our hydrogen, 1 proton. All right, do the subtraction, 1 minus 1. You got that without a calculator? 0. Normal, high quality, everyday, made in America hydrogen, no neutrons. Deuterium, 1 neutron, tritium, 2 neutrons. These are radioactive, they're unstable, they break down, they have what I call a half-life. Okay, later video for that one, we'll get into that. So those are your different isotopes. Okay, when you have an isotope, you are going to be unstable, these isotopic forms. The basic form of hydrogen is not, it's stable, but these are unstable, and they break down. So They want to become more stable. And they do that through a process of radiation. Okay, radiation. Now, there are three different kinds of radiation that is given off by things which are radioactive. Two of those are particles, and one of those is a kind of light. Light, yeah. Electromagnetic radiation, electromagnetic spectrum. All light is radiation. It's just that it's not all harmful stuff. The kind of light that we're going to talk about for radiation is bad news. You don't be messing with this stuff. Okay, you turn green and angry and the Hulk. Yeah, gamma. You've heard of that. Hulk. See what happened to him? Okay, so here they are. You've got your two particles, and they're called alpha and beta particles. These are two kinds of radiation given off by something which is radioactive. And these two are particles. They have mass. All right, particles, they have mass. The third kind of radiation is a form of light called gamma. Now, gamma is not the only harmful form of light. There's ultraviolet, makes you all red, and like me anyways. Like a lobster if I go out in it too long. The sun. Also, X-rays are nasty radiation, but this is like bad Larry radiation of them all right here. And this is given off by radioactive materials, which is really the bad stuff. They're all bad. I mean, if you were to, get hit and ingest any of these, talk about that, then not a good day for you. Especially this one. I mean, actually, we get blasted by radiation every day, every moment of every day. It's called background radiation. Okay, background radiation is natural radiation as it occurs. You get it when you walk outside in the sun. You get it from constructing materials, natural stuff here in the Granite State. We have radon, okay, and that stuff produces radiation. So we're always exposed to it. It's just that you can't be exposed to more than what would be considered safe levels, normal background levels. Otherwise, bad things can happen to you. So this is a form of light, and therefore light does not have any mass. Okay, it actually has some mass-like properties to it, but it doesn't have any mass. That's a discussion for a different day. These two particles have mass, and the beta particle and alpha particle look like this. Okay. The alpha particle is the nuclei, or nucleus, I should say. I've only got one drawn here, so I'll say nucleus. The helium atom. That's what it is. It's a helium atom, which is the nuclei of a helium atom. You might say to yourself, I thought helium. I breathe helium in you, and I can talk like this. It's fun. Yeah, that's dangerous. No. That's not radioactive helium. That's just normal, high-quality made in America helium. This is a particle given off as a result of a radioactive breakdown. Okay, and this stuff can be, this isn't good alpha particles, okay, it's high energy stuff. This beta particle, but not the helium. You can go ahead and keep breathing your helium in, okay, and make those funny voices. Go ahead, do it. Beta particles, there are actually two of them. There are two kinds of beta particles. And that is, now a beta particle, you'll sometimes see the symbol B, okay, beta, Greek letter for B, beta, that's what it looks like. Or you'll see this, an E. You can use either one. Either one's fine. I usually use E. Our textbook uses E. That's what I'm going to use, okay? But if you see it with a beta particle like this, it's okay. So beta particle. Now, a beta particle comes in two shapes and forms. It comes in this form here, or this form here. And this thing, if I wanted to make a beta particle that looks like this, it would look like that. So this is our beta particle. Again, either one works. I'm going to stick with the E's, and those are our two different beta particles. All right, you ready? You ready? I'm going to rock your world. Here's rock your world number one. Rocking your world is the following. Beta particles are electrons. They are electrons. Okay. Do you see a problem maybe up here? Problem. It's not a problem. Not for physics, it ain't. Maybe in chemistry it is. Check this out. You can have an electron that has a negative charge. Yeah, I know. We learned that. They all have negative charges. That's very good, Billy. Very good. But did you know that they also have electrons that have positive charges? What? My chemistry teacher never taught us that. That's because physics is the apex predator of all sciences. Okay, we're up here, chemistry's down here. Yeah, they don't know this stuff. We do. Yeah, there's positive electrons. Whoa! Yeah, just rocked your world, didn't I, Billy? You sure did. Now this is a negative beta particle, an electron. This is a positive beta particle, which is called a positron. You made that up. No. Wish I did, but I didn't. All right. Positron. A positron is a positive electron. Oh, I need to digest this. This is so weird. It is, I know. That's why physics is awesome. So this is a positron, and a positron is a positive electron, which is a form of a beta particle. Okay, again, and these both have, they're both particles. They have mass. That's the mass number. Okay, helium has a mass of 4. There's the mass number. You just said that these are particles, and particles have mass. And then you just pointed out that the mass is nothing. I don't get it. You're stupid. Yeah, in some things in life I am. That's true. But with this, sorry, Billy, no. I don't get it then. Okay, here's what it is. You see, electrons are assigned a mass of 0 because relative mass is 0. Now, they actually have mass. It's just that their mass is so small compared to a proton or a neutron. Okay, it takes 1,800, over 1,800 of these little electrons to make one proton or one neutron. Protons and neutrons essentially have the same mass. Okay? That's why we assign them a mass of 0. They actually do have mass, it's just that we assign them a relative mass of 0. Oh, okay, I guess I kind of get that. Yeah, thanks, Billy. So these are particles, okay, not a very massive one, assigned a mass of 0. The alpha particle has a mass of 4. And as we just went over earlier, 2 protons, and that 4 comes from the 2 protons and the 2 neutrons. Okay, so those are particles. This one here, light, no mass to it. Now, we also talk about with radiation, the ability, it's sometimes called penetration ability, or the other way of looking at it is, what do you need to stop it? Okay, what's its ability to go through things, and what do you need to stop it? With these 2 forms of radiation, they can be stopped relatively easily. The alpha particle can actually be stopped by a piece of paper. Yeah, right there. Oh, what you got? Come on, throw it. Boom, whoa, nothing. What do you got? Nothing. Oh, come on, piece of paper. What do you? Boom. Oh, piece of paper. Stop the alpha particle. You got nothing, alpha particle. Beta particle is a high-speed electron. It's moving a little faster, so it has more momentum. Boom. You can go through stuff a little easier. Start throwing beta particles at me. Ow. Stop it. Whoa. Jeez. Ow. Paper won't do the job. In fact, what you need is, not much more though, you need a piece of aluminum foil. Okay, more than paper, but still aluminum foil. So this one gets stopped by paper, this one can be stopped by aluminum foil. This one, you need lead, and a lot of it. You need what I call centimeters of lead. I mean, the more you have, the more you're able to stop it. If you have a few centimeters of lead, you'll stop like about half of it. And then it goes in the downwards curve in terms of, like, if you double the amount, you don't stop all of it. It doesn't work that way. So if I have a few centimeters of lead, I can stop like half of it. If I have a few more, I can stop like a quarter of it. And so you need to have centimeters of lead. That's heavy stuff. Okay. So this one here laughs at you with your aluminum foil and piece of paper. Goes right through it, smacks right in the face. Ow. Ooh. Okay, this one has a very high penetration ability. You need a lot of lead to stop this one. Okay, so those are what radiation is. Radioactivity is an unstable thing that wants to break down, give off energy, and become more stable. Okay? I've been giving a lot of energy in this video, so now I must have been radioactive. And now I'm giving off some energy, and I'm more stable now. I'm so much more stable. A lot of you are going, I don't think so. You're right. Now, these 3 are going to be involved in what we call nuclear reactions. And that, kids, is for the next video, nuclear reactions. Okay, stay tuned.